Hi all, very good evening. Welcome back to Java classes. So in this session, we are going to start with the second unit, Java Inheritance, and we're going to see a few examples for that concept. Fine. In this presentation, I'll explore the concept of inheritance in Java, and I'm going to provide few examples that will help you to understand it better. As you know, it is one of the important features of Java. Fine. Now, start to start with, I'm going to work with inheritance basics. Okay. So what is inheritance? Inheritance allows one class to inherit the properties and methods of another class. So here a perfect code reusability is provided. Okay. It is a process of creating a new class from existing class. Okay. The relationship which it creates between two classes at inheritance is a relationship. I said you this concept in terms of your nested class, right? So in terms of your nested class, the relationship which it creates among the classes is has a relationship, right? Whereas coming to the relationship between the two classes in inheritance is a relationship. Fine. So now in this inheritance concept, we are going to use two major what you can say terminology for working with classes, that is superclass as well as subclass. Inheritance involves two types of classes, which is superclass. It is also called as parent class or base class. Okay. And we have one more class called subclass, which is also called as a child class or a derived class. Now, what the subclass will do, the subclass inherits the attributes and behavior of the superclass. The another name for inheritance is derivation. This is very, very important interview concept. Fine. So now we're going to work with inheritance. In this, what is extending classes? So you're going to use the keyword called extends to work with inheritance. You can see in Java, the extends keyword is used to create a subclass that extends a superclass. Now, at inheritance concept, when a new class is created, it encloses the features of existing class, extending itself with the additional concepts. Is it point clear? So it is going to enclose the features of existing class. At the same time, it is going to have its own additional features. So this is how we are going to work with inheritance. Now, types of inheritance. There are multiple types of inheritances we have. So I'll just say you one by one. To start with, first one is single inheritance. Then you have multiple inheritance, multi-level inheritance, hierarchical inheritance. Okay. So let us start with the first type of inheritance, that is single inheritance. So name itself suggests, right? Single inheritance. There will be only one base class which is extending with the properties of a derived class. So let us suppose this is class A and this is class B. Now A is called as superclass and B is called as subclass. Is that point clear? So now A is also called as a parent class. Okay. And B is also called as a child class. Now, what is the definition of single inheritance? Single inheritance is when a subclass inherits from a single superclass. We have a single superclass. From that, we are deriving one subclass. Is it point clear? Now, let us go with the syntax. Now, this is the syntax for single inheritance. You're going to have one base class and you're going to have one derived class. So, class, I'm going to give base class name followed by instance variables and methods of that particular class. Okay. Then I'm going to create one more class called a derived class. Is it point clear? Right? Which extends the base class name. So this is derived class name followed by base class name, and extends is a keyword which is used to inherit the properties of one class to another class. Is that point clear? Right? So in this derived class also, you're going to have instance variables as well as methods. Okay. As I said, what are the advantages of the single inheritance? It creates a perfect code reusability and it is going to simplify the code maintenance, and also it allows for a clear hierarchical structure of different classes. This is all about you're going to learn with single inheritance. Now let us go with the example. So this is I've just done my program into the three categories, 1, 2, and 3, right? So what I'm going to do, just focus here. You'll understand the concepts more clearly. So what I have done is in the first point, I've created the base class. In second point, I've created a derived class extending your base class. And third point, I've created your main class. So this is all about your single inheritance. Just see here. So in single inheritance, you are going to have only one base class, okay, and you're going to have only one derived class, okay, and you have main class where you're going to create the objects to access the properties of your base and derived class. So let us start with the example. First of all, I'm going to see what is this program is all about. I'm going to have two classes here, right? First one is student class. Is it point clear? So this class name is student. So this student class holds roll number, math marks, physics marks, chemistry marks, and name of that particular student. So it holds all the 5 variables here. Name of that particular student, roll number, math, physics, chemistry marks. So this is all about student. And then I'm going to take one more derived class called marks. Okay, this is called as marks. So in this marks class, what I'm going to do is I'm going to take two variables. Okay, one is integer of total and one more is average, which is a float variable. So in this student class, I'm going to take name, roll number and marks in 3 subjects. In marks class, I'm going to calculate total and average. So this is all about the structure of my single inheritance. So you can see here, now, in this, I've created a method, public void details. Okay. It is, in this, I'm going to create a roll number and a name. Okay. And marks in 3 subjects. Then afterwards, I'm displaying all those things in display method. This is all about base class. So simple. In the base class, I've created a base class name with student. In that, I've created 5 variables, which holds roll number, name, marks in 3 subjects, maths, physics, and chemistry. Then I've taken one method called details. In that I have given those, I've assigned the values for all those variables, and display method, whatever the values I've assigned, I'm going to display them. Roll number will be printed here, name will be printed here, right? Physics marks 100, maths marks 100, chemistry marks 100. Fine, so this is all about your base class. Now what I'm going to do is, I'm going to take one more derived class called marks class. Marks is derived class which extends your student. So here you're extending the properties of your student class to your marks class. Is that point clear? So now in this, I've declared two variables, total and average, and I've declared one method called calculate. I'm calculating total equals to math plus physics plus chemistry, and average I'm going to calculate total by 3.0 F. I'm converting it into float. Okay, this is typecasting. Okay, now again, I'm going to use display method. So what is the purpose of this super keyword? I'll say you, okay, with the execution. Now system.out, you're printing the total as well as average, which you're calculating in this part. Okay, so this is your derived class from this point to and this point. This is your derived class. Okay, now I need to create the objects. Fine. So I'm going to take one class INH, which is inheritance. In that, I am declaring the main function, public static void main with string arguments. I need to create the object for marks. Now this is very, very important, right? So just I'm writing here, I have one class called student. Now, if I create object for student, I'll create student obj1 equals to new student. If I create object one in this way for student class, now this object one will access only the properties related to the student class. So now this object can call obj dot details, and also it can call, sorry, obj1 dot details, obj1 dot display, because as this object is created for your student class, it is restricted to call only the properties of student class. Is it point clear? So it is going to call like this. Now, but in terms of your inheritance, as I said, there is a perfect code reusability. You need not create object for student class. The object which is created for your derived class will extend the properties of your derived class as well as your parent class, that is base class. You can see here, marks obj equals to new marks you have created, then you have called obj.details. So this details is a method which is present in your student class. Is that point clear? Now you'll get a doubt, sir. Object is created for marks, but why you're calling details? Because this details is of student. See, this comes the property here. As you are extending the properties of base class student to your derived class marks. So the object created for marks class will call the properties of your student class as well. So that's what I said here. Obj.details. When I say obj.details, cursor comes to your details method and it will initialize all these values. And again, cursor returns to this point. Then afterwards, what is my next statement? Object.calculate. So cursor comes to your calculate method. In this, it is going to calculate math, physics, chemistry, as well as average. Total and average, it's going to calculate. Now, very, very important. Just see here. When I say obj.display, this is very important. You have display method here. Is it point clear? In the same way, you have display method here also. So display method is there in base class. Display method is there in derived class. So when I say obj.display, to which display method it will go? Whether it will go for your derived class display method or will it go to the base class display method? Very, very important, right? So when I say obj.display, it comes to the display method of your marks class, derived class, because object is created for your marks class. So when the object is created for its marks class, first preference will be given for the display method of that particular class itself. So when I say obj.display, it comes to obj.display of your marks class, followed by the first statement super.display. When I say super.display, it is nothing but it is calling the method of your superclass. Is it point clear enough? So when I say obj.display, cursor comes to display method of your marks class, followed by in that the first statement you have kept is super.display. It means that you're going to call the display method of your base class with the help of super keyword. The super keyword is used to interact with the methods which are present at your base classes. Is that point clear? So now when I say super.display, cursor comes to display method, it will print all these values. Again, it is going to print the total and average. First, it prints the display method properties, and after printing all these, again, cursor comes to your next, the same point, and is going to print your total as well as average. So this is all about how the inheritance works. Is that point clear? Hope this is clear. Only object created for one class is going to call the properties of both the classes. Clear? And super.display, it should be inserted as your first statement. And one more very, very important point is this concept also gives you method overriding, right? What is method overriding? See, you have display method in base class, display method in derived class. When same method names are present in both the classes, different classes, then that is called as method overriding. If you say method overloading, this display method should be present in the same class. Is that point clear? If it is present in the same class, that will be your method overloading. But one method is present at base class and another method is present at derived class, which is your method overriding. So hope this point is clear for you. Right. We'll move on to the next topic, multi-level inheritance. So what is multi-level inheritance? Name itself suggests, right? So you're going to have multiple levels of classes. So I'll show you. This is one class, this is one more class, and this is one more class. Okay, so this is A class, this is B class, and this is C class. Now this A class is going to act as base class, right? Base 1 I'm going to say, and this B class is going to act as derived class, okay? And base class for your C class. And C class is going to act as your derived class. But this is not a base class because this is the last class, right? So now this is your base class B1, and this is going to act as derived class for B1 and base class for your C. And this is your derived class. Is it point clear? So as there are multiple levels, level 0, level 1, and level 2. So this concept is called as a multi-level inheritance. Now it is very clear from the diagram, the object created for B class is going to access the properties of B class as well as A class, because there is a relationship between these two, right? Inheritance, that is extends, using extends keyword, you're going to create relationship between these two classes. Now next point is, now this is also your two classes. B is going to act as your base class and C is going to act as derived class. Right now, the object created for your C class is going to access the properties of C class as well as B class. Is it point clear? So now you can see multi-level inheritance is when a subclass inherits from superclass and another subclass inherits from that subclass, forming a chain of inheritance. You can see this is more clear for you. Subclass is inheriting to your superclass and another subclass is inheriting the subclass. Okay, this is chain of inheritance. So I'll give you one of the example. Okay, now it is clear for you what is multi-level inheritance. Let's go with the program. Okay, let's focus on this program perfectly so that you'll understand the remaining concepts. So I'm going to create a superclass or base class or parent class called student. That student class holds only two variables, name as well as roll number. And I'm going to take one more subclass called exam, right, which is going to store three subject marks. And I'm going to take one more subclass called marks, which is going to calculate the total and average. So here, how many classes I'm going to take? One superclass called student, which holds name and roll number, and one more subclass called exam, which holds three subject marks, maths, physics, and chemistry, maths, physics, and chemistry marks, and another subclass called marks, which is going to calculate the total and average. Okay, so it's more clear here. The exam class inherits the student class. Okay, so here this is your super class called student, and this is your base class called, sorry, this is your subclass called marks, and this is your one more subclass called, so sorry, this is your exam. Is that point clear? This is your exam class, and this is your marks class. Right. So now exam is extending student and marks is extending exam. Right. So this is how we are going to work with this. So what are the benefits of this multi-level inheritance? It allows for the creation of complex class hierarchies and enhances the code reusability. So the main advantage of inheritance, any type of inheritance, is perfect code reusability. Clear? So now we'll enter into the program. Just see here. So this program also includes method overriding, and also it includes super keyword. Okay, so just see here, I've created one base class called student as per my question, and I've created one more called exam that is extending your student. I've created one more class called marks that is, instead of inherit, sorry, you're going to write here extends here. Instead of student, you're going to write here. Just see here, in this class student, I've created roll number and name. Okay, so in this I've created one method where it includes roll number as well as name, and I'm creating a display one. In that I'm displaying roll number and name. First class is clear for you. Student, two variables, roll number and name, one method for assigning the values, and one more method for displaying those values. This is clear, right? Why I'm taking this easy example is, first of all, you need to understand how this inheritance works. Then afterwards, when you go into the applets and AWTs, there you're going to come with some predefined classes where you're going to inherit them. There you're going to come across some complex problems. First of all, you need to be perfect with the concept. Now, next, I'm going to take a class called exam. Okay, this exam is extending the student class. Right. So now in this, I'm going to take these variables, mass, physics, chemistry. Then I'm taking MD, okay, method, MDC. Here we have MD method, and here also you have MD method. So same method in two classes, which is inherited, right? This concept is called as your method overriding. What the point? So same method, name in different classes. which are inherited. So those methods, that concept is called as your method overriding. Now I've taken this super.md. I'll say you how it works. Okay. Now whatever the marks I've taken, I've just assigning those marks to those variables, and I'm going to take display method. Say this is display one and this is display. Those are different, right? So no need to bother about them. I'm going to print those maths, physics, chemistry marks which I've taken here. So these will be a small letters. While typing, by default they have come with capital letters, but these are small letters. Now maths, physics, and here you're going to work with chemistry. Is it point clear? Now this is one thing, and next thing is class one more called marks, which is extending your exam. Okay, so this exam you're going to extend with marks. So this is perfect structure which is given. This is student, right, which is extending your exam, and in turn this exam is extending with marks, right? So in this marks I'm going to create two variables, int total, average you can take it as float, no worries. Okay, so here I'm going to take, instead of average with integer, I'm going to declare float average. Fine. So I'm going to take get method. In that, I'm going to calculate total and average with the formulas. Then display method, right? Why it is display method? I'll say you. Okay. Now display method, in that I'm displaying the total as well as average. Fine. So now to start with the main method, whatever the programmatic language it is, the program execution starts from your main function. So I've created inheritance, public static void main, string arguments, right? This is a main function. Now you are creating object for your marks class, right? So let me write, I'm creating object for your marks class. So what all the things will be present in this object, right? So object is created for marks. So what all the properties there in marks, those will be present in your object. Okay. So mark, this is marks class. So you have total as well as average. So you're going to work with total, average. Then afterwards you have get method and you have display method in this object. Now this object can access all these things. At the same time, as this marks is extending your exam class, is it point clear? So what all the properties present in exam class will also be present in this object. So now continuity to this object, you have the same thing of another class, that is, what is that class? Exam. So in this exam, what are the things you have? You have mass, I'm writing in short, physics, chemistry marks, then you have MD method, okay, then you have display method. So now this object can call all these properties, but this object can't call the properties of student. This object can't call the properties of student because student is not inherited. Your exam is inherited. Is that point clear? Right? And next, fine. So now I need to create object for your exam. So here it is exam, not exams. Okay. So exam obj1 equals to new exam. Already you have created object. The same object can't be created. So I've taken as a different name obj1. Is it point clear? So now obj1 is for exams. So this you can see this is for exam class. So I'm going to write here what all the things present in obj1. This is obj1. As this obj1 is for your exam class, the properties present in exam are there in this. So you're going to have this one, mass marks, physics marks, chemistry marks, MD, as well as display. And also, okay, this exam is extending the features of your student. So this obj1 also consists of the properties of your student, that is roll number. Okay, then you are going to have name, then you're going to have MD method, right? Then you have disp1. Now this object1 can access all these properties and object can access all these properties. Clear? So now you see how the program execution starts. Okay, so let me erase this. So now you have created the multi-level inheritance program. So now you can see this is main method you have created. Then you have created object for your marks class. So when you create object for your marks class, okay, this is your marks class, which is extending exam. So object of this marks class can call the properties of marks class, okay, as well as it can call the properties of your exam class. So this is that exam class. Is that point clear? So what I'm going to do now, I'm going to call obj.md. MD is a method which is present in your exam class. So it goes to MD method. It is going to initialize three values and it is going to come to its respective position. And what is next one? Obj.get. So here it is get method. So cursor comes to a get method. It will calculate physics, chemistry, and mass total. Okay. And also average. Okay. And what is next one? Display. When I say obj.display, or as object is created for your marks class, the first preference will be given for your display method of your marks class. Okay, here it is display method again. Two methods in different classes with same name. This is method overriding. Is that point clear? So when I say obj.display, cursor comes to a display method. In that, the first statement is super.display. The super keyword is used to interact with your base class display method when given with same names. So when I say super.display, cursor comes to your display method, then followed by it is going to print all these three values. Okay, and next it is going to print total as well as average. After completion of this, again cursor comes to this point and it prints total as well as average. Is it point clear? Now, in order to interact with your exam class properties, I need to create object. Okay, or in order to interact with student, okay, I can create object separately for student, or I can create object for exam and I can call the properties of exam as well as student. So I've created exam obj1 equals new exam. Same object name is not valid. So object I've created, same obj can't be written here, right? So same object cannot be declared twice. So that's the reason why I've taken obj1. Okay, when I say obj1.md, cursor goes to your md method. Okay, here you're going to write super.md. When you're going to write super.md, again you're calling, see, md is same method in both base class and derived class, method overriding again. Right. So when you say super.md, cursor comes to this point, it is going to assign roll number as well as name. Again, it is going to initialize three values. Okay. So now obj1.display, when I say obj1.display, here it is display method. It is going to print all these three values. And when I say obj.display1, cursor comes to your display1 method and is going to print roll number as well as name. So is that point clear? So object created for one class can access the properties of different classes. So this is level. Student is at level 1 and exam is at level 2 and marks is at level 3. So this is called as your multi-level inheritance. Is that point clear? How we are going to do? Okay. Only thing you need to keep in your mind is if you create object for this exam, as it is extending student, the object for exam class is going to interact with this exam as well as student properties. And if you create object for your marks, that is going to interact with exam as well as marks. Is that point clear? So this is all about your multi-level inheritance. Coming to next point, that is hierarchical inheritance. What is hierarchical inheritance? It is like a chain system. Okay. Hierarchical inheritance where you're going to have multiple subclasses. See, one superclass you're going to have. For this one superclass, you're going to have multiple subclasses as that of your chain system. Okay, this is base class, this is derived class 1, and this is derived class 2. In the same way, you can have multiple derived classes also. You can say D3 and you can have multiple derived class D4, but base class is 1. Okay, but derived classes are 4. So object created for this derived class will access properties of these both classes, base and derived. Object created for derived 2 will access the properties of derived 2 and base class. And object created for D4, it is going to access the properties of D4 class and also base class. Same thing. Okay. So now hierarchical inheritance is when multiple subclasses inherits from a single superclass. So this is single superclass. Multiple subclasses are derived from this single superclass. So this is your hierarchical inheritance. Coming to the example, right? You can take any of the example. Okay, just generally sample example I've taken here for your understanding, but program also you can take, where you can take student class, okay, followed by marks class, followed by exam class. So derive few instance variables here and methods here, and derive few instance variables and methods here, derive few instance variables and methods here. So this is how we are going to create a hierarchical inheritance. Only single base class, multiple derived classes will be there. So consider a superclass called country. So I'm going to take a country and subclasses like in that country, there are number of countries. Okay, USA, Canada, Mexico. Okay. Now each subclass inherits the properties and methods of the country class. So this USA is going to interact with country, right? Then this Canada is also is going to interact with country, and Mexico is also going to interact with country. So USA, Canada, and Mexico are subclasses. Country is a superclass. In the same way, if you take here student, that is the base class, marks is subclass, as well as exam is one more subclass. In this way, you can relate. Okay. Next is advantage. What is advantage for this using this hierarchical inheritances? It provides a structured and organized way of to represent the relationship between the entities. So all these are entities. So all the relationships, structural relationships, right? Or you can say um a structured and organized way to represent the relationships between the entities. That is one of the major advantage of your hierarchical inheritance. You can take example of student marks and exam, and you can do the hierarchical inheritance program. Clear? And next, multiple inheritance. Name itself suggests. So it is quite different from your hierarchical inheritance. In hierarchical inheritance, you're going to have single base class followed by multiple derived classes. Is that point clear? Now, whereas coming to this, in terms of your multiple inheritance, you're going to have multiple base classes followed by single derived class. So, which is not possible in terms of Java because Java does not support the creation of multiple base classes. So multiple inheritance is not supported by Java. Okay, let us see. Okay, multiple inheritance is when subclass inherits from multiple superclasses. This is subclass which inherits from multiple superclasses. This is one superclass. This is one more superclass. Clear? Then suppose we have a superclass called bird. Bird is one superclass. Okay. And we have another superclass called mammal. Okay. This is one superclass. This is one more superclass. So these two superclasses. Okay. And we have one more subclass called parrot that inherits the attributes and behaviors from both the superclasses. So this is your rabbit. Sorry, parrot. Clear? So this is the example you can derive for your multiple inheritance. So what are the challenges faced with multiple inheritance? Multiple inheritance can lead to ambiguity and complexities, making the code harder to understand and maintain. So as multiple base classes are there, it is bit difficult to handle these challenges, right? Next, multiple inheritance is not directly supported in Java. Java does not support multiple inheritance directly, but it can be implemented using interfaces. Very, very important interview question, right? So multiple inheritance can be supported in Java using interfaces. Clear? And next, already we have seen what is method overriding. Method overriding occurs when a subclass provides its own implementation of the method that is already defined in superclass. So in superclass, there will be one method which is already defined. And the same method you are going to define in terms of your subclass. So same method name in two different classes, that is method overriding. Example, consider a superclass called shape. I'm going to consider a superclass called shape with a method called calculate area. Okay. The subclass called circle. So this is my subclass, which is circle. Okay. And can override this calculate area. So in this again, calculate area is also present. This is overriding because this calculate area is present here as a method, and in circle also you can write this calculate area. Okay. So in the same way, you can create one more class and you can do. But as per my example, So this is method overriding. Calculate area and calculate area in shape class and circle class. Okay. Then what are the benefits of method overriding? Method overriding allows for runtime polymorphism and allows implementation of specific behaviors in subclass. So it mainly focuses on the concept called runtime polymorphism. Runtime. Compile time is one thing and runtime, it is at the execution of the program. So polymorphism, we have seen same method used for many purposes. So poly refers to many and morphism refers to forms. So polymorphism is nothing but concept of many forms. So you can see this is one form calculate area in one class. The same in circle class also we have calculate area. Is it point clear? So this is how many forms that represents polymorphism. Hope this is clear. What is method overriding? And the next important thing is first you have learned superclass. What is superclass? To interact to interact with the properties of your base class, we are going to use super keyword, super dot display. In the previous example we have seen, right? So when you say super dot display, it goes to super class display method. So interact with when methods are given with the same name, to interact with the method of base class, you're going to use the super keyword, right? And afterwards, you have very important keyword, which is final keyword. Now, what is final keyword? Name itself suggests this final keyword can be done with the help of three concepts. So this final keyword can be used with instance variables. This final keyword can be used with classes, and this final keyword can also be used with methods, right? So each and every point or each and every usage have its own importance. Now go with the first one. You when it is used with instance variables, what is its scope? How it is going to react? So when you are using this final keyword with instance variables, declaration of variable and initialization of variable should be carried out simultaneously. So in this way, you're going to declare and you're going to initialize the value at the same time. In some cases, you're going to create only int a, and after somewhere in the program, you're going to declare some a equals to 10. So this is not valid in terms of final keyword. Whenever you're creating a final or whenever you're using an instance variable with final keyword, the initialization as well as, okay, and declaration of that variable should be carried out on a same line. Okay. Final variables cannot be modified. You can see here somewhere I've taken int, and after some time when based on my requirement, I'm going to take a value as 100. Now this 10 will be overridden by 100, right? In terms of your normal program. But we're coming to your final instance variable when you're giving a equals to 10 and when you give a equals to 100, it is not going to take. Final variables cannot be modified. So this 100 cannot be modified. So that's what I've given. Final variables cannot be modified. It can be accessed anywhere in the class, either inside the method or outside the method. Wherever it is, you can access that inside a class. Now, this is the syntax for that. Access specifier, which is public, return type, which is void, and which is final. Okay, final variable, that is final int a, and a value I'm going to assign it as 10. So this is how we are going to declare final keyword with instance variable. Now the same thing, final keyword can be used with classes. So when final keyword is used with classes, those classes cannot be inherited. That class cannot be inherited. Example, you can see, I've taken one class called marks, which is attached with final keyword. Then I've created total as well as average, and I've calculated just total and average. So just simply I'm saying, okay, I've not assigned the values, but generally how it takes place. Okay. Now what the next class? I'm creating one class called exam, which is extending your marks class. So this concept is completely wrong because whenever you create a class with final keyword, that class cannot be extended. Is that point clear? Generally, if you don't create final here, this is correct. But if you create final, it means that this class marks cannot be inherited to this exam because it is finalized. Hope it is clear. And next one is, so that is a point. So when we are used with these classes with final keyword, those classes cannot be inherited. Next one is it is used with methods when when you are using with methods, we have a concept called method overriding. Hope it is clear. So that method overriding cannot be possible when used with final. Example, class marks I've taken. Okay, I've taken public final. This is very important. Final void h, then I'm printing hi. Now this class, one more class I'm taking, I'm extending that with marks. Okay. Now I'm going to create public void h. Already public void h is created in base class. In the same way, public void h, when I'm going to create in terms of your derived class, right? So this is completely not feasible. That is wrong completely. So now by taking the concept of final keyword, you can differentiate or you can just analyze three things. When used with instance variables, that variables cannot be modified. Okay, that can be accessed anywhere in the class, and initialization and declaration should be carried out simultaneously. Next, when it is used with classes, classes cannot be inherited. That's what I've kept here wrong. Okay. Next, that method cannot be overridden when that final keyword is used with methods. Hope this is clear for your final keyword, right? So the very, very important topic is abstract classes as well as your interfaces. Both may be seen, but the point is it has some separate features and it has some this. Okay, now you can see. Okay, so now what is this abstract class? An abstract class is a class that cannot be instantiated, right? Instantiated in the nothing but you can't create the object directly for this abstract class. Rather, you can share the memory of derived class. Okay, how that will I'll show you with example, and is used as a blueprint for other classes. It can contain both abstract methods, it can contain non-abstract methods, it contains static methods, it can contain constructors, right, etc. Now, interfaces. Now, what is the difference when it is taking all these things as normal class? But for a normal class, if I take, suppose class add is a normal class. Okay. For this add class, what I'm going to do, I'm going to create an object. Add class add obj equals to new some class name. Is that point clear? So generally this is for normal method, you're going to create the object. But in the same way, for abstract class, this direct way of new keyword is not assigning a memory using new keyword is not possible. Okay, so abstract class cannot be instantiated, and it can be a blueprint of other classes. It contains all these things. Next point is interfaces. As I said, abstract class is collection of pure abstract and non-abstract methods, static methods, constructors, everything. But whereas coming to interfaces, they are not going to consider all these things stuff. It is going to consider only pure, okay, abstract methods. Is that point clear? So now interfaces are called as pure abstract methods. So an interface is a collection of abstract methods and that classes cannot be implemented. It defines as contract that implementing class must follow. Fine. So that is the logic. Now usage. Abstract classes and interfaces are useful in designing complex systems and achieving the abstraction and modularity. Interfaces are also used for implementing the multiple inheritance. That's what we have seen, right? Interfaces used for your implementing multiple inheritance. Clear? So this is all about the abstract class and interfaces basics. In tomorrow's class or in continuation with the class, I'm going to give the example for abstract class as well as interfaces and accessing procedures by giving the definitions. Clear? Chalo. Bye all.